Giovanni asks, isn't the size of the blockchain an issue for the ordinary PC? Currently, my Bitcoin folder size is 153 gigabytes. Definitely an issue preventing people to be part of the transaction validation process. Giovanni, you're correct. In fact, an even bigger problem is the cost of bandwidth, because in order to create that blockchain of 153 gigabytes on your hard drive, you probably transmitted and received close to a terabyte of data across your internet connection. In many cases, a single node is connected to 8 other nodes. For every block they receive, they transmit it 8 times to 8 neighboring nodes, which results in 8 times the amount of data being transmitted outbound. And they'll also receive and retransmit blocks that eventually don't end up in the blockchain, orphan blocks. Those still will get transmitted. And they will support uploading the blockchain again and again to clients that are bootstrapping for the first time, to thin clients that are syncing for the first time. Yes, disk and bandwidth are great considerations. This is the primary argument for keeping the block size to a limited size in order to allow as many people as possible to run fully independent validating nodes around the world to create a robust decentralized network, with the idea that if the space capacity bandwidth requirements of nodes escalate rapidly, as we're seeing, for example, on the Ethereum chain, eventually that's going to lead to fewer and fewer people running nodes, more and more corporate data center centralized solutions for running nodes, which then become much easier to coerce, to sue, to shut down, to attack, and make the network less robust. Daniel asks, as we see in session 2, the mechanism that Bitcoin uses to confirm transactions and resolve the Byzantine generals problem is based on consensus of the network. We now have the pressure for activating SegWit2x on November 1st. It may cause a hard fork in the blockchain. Is this an attack on the Byzantine generals problem solution? No, it isn't. And the reason it isn't is because fundamentally the consensus algorithm, especially of the Bitcoin blockchain, but more generally of blockchains, is not a coercive system. It's an opt-in system. And the decision as to which is the correct chain is an entirely subjective decision that is made on a node-by-node basis. So which is the real Bitcoin? There is no general answer to that. You each choose which is the real Bitcoin for your perspective by running a node that validates with a set of consensus rules that you believe are what represents the real Bitcoin. So it's an entirely subjective experience. If you have 16 million people who are running Bitcoin, they can form 16 million different impressions of what they believe the real Bitcoin is. Now, out of that, of course, something emerges, a majority perhaps, that has more economic activity, more market traction, more hashing power. But that is not always clear-cut. So in the end, the only thing that matters is the individual perspective. You are not coerced into making that choice, and it's an opt-in system. The Byzantine general problem solution, or the consensus algorithm, operates within the set of nodes that are following those consensus rules. So if part of the network forks off, that's not a failure of the Byzantine generals problem. The consensus algorithm continues to operate. It continues to operate on 2 separate networks, each of which is fully enforcing the consensus algorithm, is fully achieving Byzantine general fault protection, but separately from the rest of the network. I think one way of looking at this is the idea of voluntary cooperation is to imagine it this way. Let's say you have a basketball court, and you have 12 people who show up, and they want to play a game of pickup basketball. And maybe 8 of the people who are there want to make sure that the rules of this particular game of basketball are somewhat softer, meaning that aggressive fouls or aggressive defense, few thrown elbows, maybe a bit of shoving and pushing is tolerated. They want to play a slightly harder game of basketball. And 6 of the people there, or maybe 4 of the people there, don't want to do that. They want to play a less rough game. Well, the good news is that 8 of them can play on one side of the court, and 4 of them can play on the other side of the court, each following their own set of rules, not stepping on each other's toes, and fork the basketball court in two. And so then the question is, do the rules of basketball still apply? Well, yes. In each of the 2 games that are happening, the rules of basketball have been preserved according to whatever those rules are, based on the interpretation of the people who are participating in that game. And nobody's forced to join one or the other game. In fact, they can just take their ball and go home and decide not to play that day. And really, that's what consensus is in a very simple way. The next question is proof of work consensus, developer consensus, miner consensus, exchange consensus, wallet consensus, wallet developer consensus. Can you please develop or expand on these forms of consensus? Yes, one of the questions that comes up often is who decides what the rules are? And the obvious answer is the miners decide what the rules are. But that's not actually true, because the miners operate on a chain because it's profitable. And it's profitable only if the underlying currency can be sold on exchanges in order to pay for their electricity. And the exchanges will only accept it if it's on the chain that they consider valid. And the exchanges will only consider a chain valid if their customers who are buying and selling on that chain consider it valid. And the customers will only consider it valid if the wallets they're using it consider it valid. And the wallets will only consider it valid, and the customers will only consider it valid if they can use that cryptocurrency to buy things from merchants. And the merchants will only consider it valid if they have code to run. And all of the above categories will only consider it valid if they have good, well-maintained, solid software to run, which means that the developers must consider it valid. But the developers will only consider it valid if they can spend their coins, et cetera, et cetera. Essentially, there is an interdependency between all of these constituencies, and all of these constituencies of consensus are themselves overlapping. I am a user. I also am a wallet user and an investor. I can also be a developer. I might even be a miner too. So some nodes and some users belong to multiple different constituencies. Many of the constituencies have overlapping functions. Developers are also users of Bitcoin. Some exchanges may also be mining. They may also run wallets, and the people working at those exchanges are also themselves users. Maybe they also sell T-shirts, so they're merchants. Everybody has to agree, and essentially, everybody decides for themselves what rules of consensus are valid. And that decision is made on an individual basis, but the emergent reality happens across all of those individuals together through marketplaces, through essentially the actions of a free market.
Okay, this one's going to be a bit controversial, but I'll tackle it anyway. Sesame asks, how does a proposal fail to proceed after having majority support from miners? I'm studying the events of SegWit2x, and I'm having trouble consolidating in my mind how SegWit2x failed to proceed on a technical level. People often cite SegWit2x as an example of how users running full nodes can keep miners in check. I hope to gain a better understanding of how exactly that works with this question. I understand that more than 80% of miners signaled in support of SegWit2x as per BIP 8 and BIP 9. But what is the mechanism by which this proposal failed? Was the proposal never locked in because of an insufficient percentage of blocks with a bit set were mined during the difficulty retargeting period? What role did the users running full nodes play during SegWit2x to resist such a change? So if you don't remember all of this, this is from the deep, deep history of Bitcoin, which means 18 months ago. And this is the scaling debate. And during the scaling debate, especially during the summer of last year, we saw everything come to a head. Starting in the spring, a number of proposals were made on how to solve the scaling debate. And different groups within Bitcoin positioned different proposals, including SegWit2x, which was a proposal to simultaneously implement SegWit and an increase of the base block size to 2 megabytes, which effectively would have increased the base block size to 16 megabytes, because SegWit would multiply that by another factor of 4 almost. So that was one proposal. And then SegWit, which was due for activation and was being activated by a new technique called BIP9, which is a mechanism for signaling using a binary field within the header of the Coinbase transaction. And there was a previous system called BIP8 that was partially used in this whole debate. And then there was a lot of flag waving. Let me explain what I mean by that. Miners have the ability in the Coinbase to put some text that signals their intent. And this isn't basically part of the protocol itself. It's like waving a flag, right? It's like putting a bumper sticker on your car. It doesn't change how the car operates. It just tells people around you what your particular position on an issue is. So let me clarify for you, Sesame Meow. You said you understood that more than 80% of miners signaled in support of SegWit2x as per BIP8 and BIP9. They didn't, in fact. There was no BIP8, BIP9 proposal for that. What was happening was that within the Coinbase transaction, people had the bumper sticker that said SegWit2x. But they weren't committed to switching over the software in order to run a version that would actually activate that change. So in that way, we've got to look at the difference between signaling that doesn't have a material impact on the protocol, which is cheap to do because all you're doing, bumper sticker doesn't cost you anything. You're not putting money on the line. You're not changing what you're doing. You're simply putting a bumper sticker versus committing in the protocol under a specific software package to run a specific set of consensus rules by a specific date. So the reason that proposal didn't garner enough support was because there was enough resistance from groups that were not miners. So consensus is made by multiple constituencies. There's economic interest, which includes exchanges. So exchanges get to have some power because if they decide to list or not list one of the forks, that gives them control over what their users do. And exchanges run nodes, and they run infrastructure through which an enormous number of transactions happen, as well as an enormous number of transactions that happen off-chain on the exchange's own databases, internal payments between users, etc. And again, the exchanges have a lot of control over that. Merchant processing services that process and convert Bitcoin to fiat for merchants who don't want to hold Bitcoin, or that simply aggregate Bitcoin and offer various e-commerce facilities like carts and integration with WordPress, WooCommerce, stuff like that. They have power in the system. You have the big investors who are trading, and they have power in the system by deciding what they're going to buy and sell and whether they're going to short or long various forks. And then you have the users, and some of those users may also be running full nodes, and they decide which blocks and transactions they're going to forward by choosing which software they run. So in this particular case, these economic interests were diverging. And as a result, miners didn't have, in this particular case, the confidence to move ahead and force that change on the network because they anticipated that they wouldn't necessarily have enough support. At the same time, there was a big movement called user-activated soft fork that basically had users using their nodes to impose an embargo on miners that didn't activate SegWit by August 1st of 2017. And that had some influence too. So the reason the proposal failed to proceed was because it never had in-protocol support with software nodes to a level where it could fork the original implementation. And keep in mind, 2x, the 2x part of SegWit2x, would be a hard fork. It would require a non-backwards compatible change that broke consensus, whereas SegWit itself was not a hard fork, it was a soft fork. In the end, the miners decided to drop the SegWit part, do the hard fork, and do just the 2 megabyte hard fork in the form of Bitcoin Cash, instead of doing both SegWit and 2x. So the miners did proceed. They proceeded to fork Bitcoin Cash, and Bitcoin got SegWit, and Bitcoin Cash got its base block increase with a hard fork. They decided explicitly not to put the SegWit component in Bitcoin Cash. So that's how it played out. This is a complex balance of economic interests, and these are huge economic interests. You take a vote against consensus, you have to be willing to risk your investment. And in the case of miners, you've got this enormous infrastructure investment. And that infrastructure investment in any existing Bitcoin or Bitcoin Cash or other coins they have or other forks they have could be affected by those decisions in a way that costs millions of dollars. In fact, we're beginning to see that some of these decisions did have an impact in the hundreds of millions of dollars for some of the miners. So it's not as simple as it appears at first glance.